All right, Math 3, Unit 3, Section G, which goes along with Worksheet 7. Today we're going to be talking about factoring the sum and differences of cubes. So what does sum mean? Good. And difference means? Subtracting. And we have learned how to factor squares, right? Cubes are something different. These are the formulas for factoring. Notice this one is your sum of cubes, and this is your difference of cubes. Okay, if we're going to go ahead and make this chart right here. So this is just a list of some of the perfect cubes. So 1 to the third power is what? 1. 2 to the third?
8.
Good. 3 to the third?
27.
4 to the third?
64.
5 to the third?
125.
That was amazing. 6 to the
That's
third?
all I know.
Oh, that's it.
That's it.
Anybody know 6 to the third? Okay, it's 216, and you would be able to get that if you used a calculator. 7 to the third is 343, and 8 to the third is 512. And these are numbers you're going to end up seeing. You want to hopefully recognize them as cubes. I'm sure some of these smaller ones you guys notice are cubes. Yeah. Okay, so when you're factoring, there's a couple things I want you to notice. So the first thing is you first have to be able to write both terms as cubes. And that's the same if it has a minus sign or a plus sign. If you notice here, what they've done for the a plus b is they've just taken off these cubes. And so whatever the cube is, it just becomes that without the cube for your first parenthesis. And the second, with the differences, notice it's exactly the same. So if it has a plus here, it's going to have a plus here. If it has a minus here, it has a minus here. Yes? Okay. Then, when you go through here, and I'm going to show you a couple ways of doing this, but this first term here is the first term squared. The middle term is these two multiplied together, but it's the opposite sign. And then the last one is always positive. So whatever b is, it is going to be b squared, and it will be always positive. So they have these words, SOAP, to help you remember for factoring. Anybody have any idea what the S stands for?
Sum.
Close. Because notice that it's the same for either if it's subtracting or adding. So what do you think the S is? Close. It's the same. So what do they mean by same? Well, whatever the original problem was, that sign stays the same. Okay, this sign right here, if you compare it to your first sign here, or even this one right here, what do you think the O stands for?
Opposite.
Very good. I don't know if I like writing down like that. I might just do like this. So it's actually the opposite sign. And you could even write this one as same sign. Okay, and then AP. So anytime you square something, it always is what? Positive. Whether it's negative or positive, it's always positive. So guess what this A and P stands for? Exactly. Okay, so we're going to get into just kind of attempting these examples. The first thing whenever you're factoring, though, is you always want to check for GCF first. A lot of times it won't be there, but there are some cases where it is. Okay, so, all right. So looking at this first example, is there a GCF? No. So now we need to write them as cubes. Okay, so what could I write? How is 8 as a cube? Good, 2 to the third power. And so I'm going to end up writing this as 2x to the third power. So 2x ends up being my A term. Is that okay? And then 125, how could I write that as a cube? So I have 5 to the third. Okay, so what would my first parenthesis be?
2x plus 5.
Good, 2x plus 5. All we do is just take off the cubes, and that's my first parenthesis. Now, your second parenthesis, there's kind of something to help you not mess up. And so what you can do is, see how we have 2x to the third and 5 to the third? If we write those in order, I write them as 2x times 2x times 2x, because there's 3 of them. And then I'm going to write out the 3 5s, 5 times 5 times 5. So for your first term, you're always going to take 2 of them and multiply them together. So if we multiply 2x times 2x, what does that make? 4x squared. Good. Okay, then you have to remember my next sign is going to be what? Negative, because it's going to be opposite of whatever my first sign was, so we have a minus. For my middle term now, I multiply these two together, and what is 2x times 5? 10x. And then we know that our last term, the sign is always positive, so I'm going to put a plus. And then 5 times 5 is 25. And that's it. This part right here is not factorable. Okay? We're going to end up trying to factor it later, and because it's not factorable, we'll have to use the quadratic formula. But you can't factor that any further. Okay. So the shortcut from not writing this out is that this 2, so if 2x, if you square 2x, 2x times 2x is 4x squared. This middle term, you multiply those two together, 2x times 5, and you just have to remember it's the opposite sign. And then the last one is the last one squared. Okay? But if you write this out, it will always work as well. Okay. So let's move on to the next one. How could I write 1,000 as a cube? Do you guys know?
10.
Good. And then for my next one, I'm going to write that as wy cubed. Oops, wy cubed. So we have our two terms kind of set together. So my first parenthesis will be what?
WY minus 10.
Close.
10 minus wy.
Yeah, you want to keep them in the same order. So we have 10 minus wy. So let's go ahead and write this out again just like we did over here. So we're going to have 3 10s, so 10 times 10 times 10. And again, remember to write them in the correct order. And then we'll have 3 wy's. So my first term will be 10 times 10, which is, good. What sign will be next?
Addition.
Addition, because this one is always the opposite. Okay, 10 times wy is,
10 wy.
and then the last one is always positive. And how would I end up writing that one?
Squared y squared.
Very good. And that's it. That's your answer. How many negatives are in this answer? Or minus signs? 1. How many minus signs are in this one? 1. So whenever you factor, there will always only be 1 minus sign. So that's another way to kind of like go back and double check that you did the correct signs. Okay, next one. Do we notice a GCF? What would be a GCF? N. Okay, so I'm going to first factor out my GCF, which is n. Now I have 216 n to the third plus 1. So now I need to write each of those as squares. So how can I write 216 as a square? Good. So I'm going to kind of have double parentheses here. So we're going to have 6n to the third power, because my 6 is cubed and my n is cubed, plus, and then I have 1 cubed. And it's important to always write those as cubes so you don't mess up, okay? And so now, when I'm factoring this out, what will my first parenthesis be?
16n plus 1.
That's supposed to be a 6, right? So 6n plus 1. And then let's go ahead and write these out again. So we're going to have 6n 3 times. and then 1 3 times.
This one.
So in my parentheses is going to be what?
36n squared.
Good. 36n squared minus 6n. Good. Plus 1. That's it. Okay, next one. GCF. So you can see that those are not cubes right now, right? And so we can see that they're both even numbers. Hopefully you notice they're both evens. So you might just start by dividing out by 2 and then seeing what happens. So if we divide out a 2, a GCF of 2, what am I left with? 512
Yeah, that's what I mean.
minus 27 m to the 6th. Are both of those cubes? Is there anything I could factor out more? And do you guys remember the shortcut for seeing if something's divisible by 3?
You add all the numbers together, and if it's divisible, 3.
Exactly. So like 512, if I were to add this, 5 plus 1 is 6 plus 2 is 8. 8 is not divisible by 3, so 512 is not divisible by 3. Okay, but if we look at our perfect cubes, we can see that 8 is actually 512. So that means I have 8 cubed minus, and then 27 is what?
3 cubes.
3 cubes, so I'm going to have a 3. Now, this is where some people get confused. We want it to be a cube on the outside, right? And powers to powers you multiply. So the numbers we're going to use, what two numbers that would use 3 would work to multiply to be 6?
2.
2. So that means, I don't know if I'm talking correctly, but so it's going to be m squared to the 3rd power because we want the 3 on the outside, and 2 times 3 ends up making 6. Okay, is that good?
So pretty much you just try to make the.
So you want the outside to be a 3, and then whatever other number would make a multiply to be this one is what goes on the inside.
Will always be okay, like the outside.
Mm-hmm. Yeah, when we're dealing with cubes, yes. Okay, so that means that my first parenthesis is going to be what?
8 minus 3m squared.
Good, 8 minus 3m squared. Okay, and then we can go ahead and write these out. So we're going to have 8 times 8 times 8 times 3m squared 3 times. So in my parenthesis, the first term is going to end up being,
64.
good, and then
Plus.
plus, and then we have 8 times 3 is,
And 4 is square root.
good, and then our last one is always positive, and we get 3 times 3 is 9 m to the 4th. Okay, any questions?
So the positive before the 24, does that come from the starting equation?
Yes. So what happens is the starting equation was minus, and then this one is always the opposite. Remember SOAP? So it's the same sign from your original equation, and then the opposite sign, and then always positive. Yes. Oh, it's okay. I factored out a GCF of 2. So 1024 divided by 2 is 512. So there is a GCF of 2. I could divide out a 2 from both of these. So when you divide this by 2, it's 512, and 54 divided by 2 is 27. Okay. Any other questions? Okay, let's move on to the back. Okay, so it says for each function, write it in factored form, then determine the real and the imaginary zeros. Okay, so we're going to start by factoring, and then I'll talk about the real versus the imaginary. Do you guys ever remember learning about imaginary numbers? Okay, so today that will be new. All right, so let's start by factoring. what am I always going to do first?
GCF.
GCF. Is there GCF?
Yes.
What is it? X. Okay, so I'm going to take out an X, and then I have X to the third plus 343. Okay, so now the next thing I need to do is make sure I can write each of these as what? Cubes. Okay, so I have X, and then this is a cube, X to the third, and how do I write 343 as a cube?
7.
Good. Okay, next we have our first parenthesis, which will be
X plus 7.
X plus 7. And then my second parenthesis, we're going to write it out. So we have X, 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 and a 7, 7, 7. And so we take the first two, and that becomes
X squared.
X squared. The next two become,
7X.
and will be plus or minus?
Minus.
Minus 7x. And then the last two, 7 times 7 is 49. Okay, and then this is f of x. Okay, so to find our real zeros, each of these I can set equal to 0. Okay, and so x equals 0 is my first, and then this would be x equals what?
-7.
-7. Okay, and these are basically your real zeros are the ones that are on the graph. Okay, so I'm gonna, right down here it says real zeros, I'm gonna just kind of make a note, oh my goodness, that these are the points that are on the graph. Oh my goodness.
No, you can't see it.
So we have x equals 0 and -7. Now there's imaginary zeros, and those cannot be put onto the graph. Okay, and so we're going to do the same thing back up here with this factor. We're going to set it equal to 0. Okay, so we have x squared minus 7x plus 49 equals 0. And that cannot be factored. There aren't any numbers that multiply to be 49 that add to be -7. And so we're going to use the quadratic formula. So just in case you have forgotten that, I'm just going to write that up here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And it sounds like some of you remember the song, which is good,
I
because
hated this song.
I never learned this.
but you remembered it, right?
Sadly.
Yeah. If you haven't heard the song, if you just go onto YouTube and search for quadratic formula song, you will be pleasantly surprised at how many videos there actually are. Okay.
You say that a lot, Jordan. And it's all recorded too.
I didn't hear it. Whatever he said. Okay, so using the quadratic formula, negative b would be +7, good, plus or minus the square root of b squared, so we have -7 squared, minus 4 times a is 1, times c is 49, all divided by 2a, which is 2 times 1. So then I like to go through here and kind of simplify. So what is -7 squared? +49. And then when we multiply 4 times 1 times 49, that makes what?
196.
Good. And that's minus 196. And what is 49 minus 196? You could use a calculator, but it equals -147. So when I write this out now, I have 7 plus or minus the square root of -147 all over 2. Now, back in your previous math classes, when you got a negative under a root, your teachers were just saying, okay, just write it as no solution. Well, now that you're more sophisticated, this is where you have your imaginary roots. And one thing that you need to know is that the square root of -1 is I. I standing for, yeah, which is imaginary, okay? I imaginary. Okay? I know. That was pretty tricky. Okay. So anytime you have a negative under a root, you bring that negative out, and when you bring it outside, it just becomes an I. So I have 7 plus or minus I root 147 all over 2. And if you could simplify that root, like break it down to your factor tree and find pairs of numbers, you would, but 147 doesn't end up factoring down. So that's my answer. So my imaginary zeros are that x equals 7 plus or minus I root 147 all over 2. So we have our real zeros and our imaginary zeros. Yes? Good? Okay. All right, last one. And for time's sake, we're going to just do this one together. I'd normally have you do it on your own. But 64, how can I write that as a cube? Good, so we have 4 cubed minus x cubed. And on this one, there wasn't a GCF, so I didn't take anything out. What will be my first parenthesis?
4 minus x.
Good. 4 minus x. And then we're going to go ahead and write out 4 times 4 times 4 times x times x times x. So in my second parenthesis, my first term will be 16. And then my next sign will be what? Plus. And then 4 times x is 4x. And then my last term is x squared. Okay, so what will be my real zero on this problem? 4. If you were to set this equal to 0, you would end up getting x equals 4. If you're ever not sure, set it equal to 0 and solve. So I'm going to go down to my real zeros there at the bottom and just write out that x equals 4, because that one now I'm done with. So for my imaginary zeros, when you're using the quadratic formula, what order does this need to be in? Descending order. Good. So a lot of people, if you don't, you might use this as the A. That would be incorrect. So x squared plus 4x plus 16 equals 0. And so that means that my A is 1, B is 4, C is 16. So negative B is going to be negative 4 plus or minus the square root of 4 squared minus 4 times A is 1 times C is 16, all divided by 2 times 1. What is 4 squared?
16. Got it that time.
Good. Minus, and then I have 4 times 1 times 16, which is
64.
good. And what is 60 minus 64? Negative 48. And so we get negative 4 plus or minus the square root of negative 48 all over 2 times 1, which is 2. Okay, and then what happens with the negative under the root?
Imaginary.
I know, crazy. It's like you don't even see it. Negative 4 plus or minus I root 48 all over 2. Now 48, can 48 break down?
C.
Okay, so what two numbers do you think of when you think of 48?
6 and 8.
Mm-hmm. And you could do it whichever way you want. You're going to make your factor tree, and then 6 breaks down to 3 times 2. And then 8, I'm just going to write 8 as 2 times 2 times 2, so it's in our factored form. So if you notice, there's a pair of 2's and another pair of 2's and a 3 left over. So when you write this one out, we get negative 4 plus or minus, and then what happens with those 2's?
They like go.
They go on the outside, so each group, but this group becomes a 2 and this group becomes a 2. And so that means I'd actually end up with 4i root 3 all over 2. Are we okay with that? Because there's one last thing. And what's the last thing?
Divide by 2, right?
Yeah, since two has to be able to go into this number and this number, but it does. So I can cancel out this 2 goes into here 2 times, 2 goes into this 4 2 times. So my imaginary zeros end up being x equals -2 plus or minus 2I root 3. Questions?